Lesson 6-2. Math time. 6-2. That's right. Length, area, and volume today. Okay, we're going to relate all three dimensions because length, 1 dimension. Area, 2 dimensions. Volume, 3 dimensions. All right, you can turn in your books to page 235. Page 235. So we see length. Length tells how wide, tall, or long something is. Length is something you can measure with a ruler or a measuring tape or your yardstick. Finding length requires one measurement, one-dimensional, from point A to point B. Okay? And they have a sample on the side over there. It says length is one-dimensional, and length shows 1 centimeter from one end to the other end of a line. Area tells how much surface a figure covers. How much surface, how much area is covered by something. 2-dimensional, because we have length and width. 2-dimensional. Covers one direction and the other. Okay? Square units is what we measure with. Volume now is 3-dimensional. Takes that 2 dimensions and adds the 3rd dimension, which is either height or depth. Volume tells how much space an object occupies. 3-dimensional space. We are 3-dimensional human beings. We have a height, and we have a length and a width. The area we covered. Okay? So, the big difference is the dimensions. Length, 1-dimensional, measured with a ruler only. Area, we use a ruler to measure the 2 dimensions, but then we measure that in squares. Squares, area squared, unit squared. Volume is units cubed. We have the area, the base, capital B base, or length and width, and then we add the height or depth to that, 3 dimensions. Okay? Basic intro into length, area, and volume. Now, let's look and see if we understand what we're measuring here. Tell if you need to measure for length, area, or volume. Then write the number of measurements you would need to make. So, for example, number 1, how much water is in a swimming pool? How much water is in a swimming pool? That would be volume because you have 3 dimensions. There's how long the pool is, how wide it is, and then how deep it is. Okay? So that would be volume, which is 3 measurements. Okay? How tall are you? Well, that's just 1. From the ground to the top of your head, that would be length or height, whatever you name it, but it's 1 measurement. Okay? Look at 3 through 8. Write down what measurement you use, length, area, or volume, and how many measurements you would take. Pause your video and do that now. All right, I am going to use just letters for this. V for volume, L for length, and A for area to answer these questions. How much carpet is needed for a floor? We know we measure the area, 2 measurements for carpet, length and width. How far is it from a doorknob to the floor? That would be length, just 1 measurement. Number 5, how much sand is in a sandbox? Now we're talking volume. We have length and width. How big is the sandbox? How much surface area to cover? And then how deep? That's the 3rd measurement, volume. Number 6, how much wallpaper is needed for 1 wall? That would be area. Length and width of the area on the wall. How long is a string? Long is length, 1 measurement. How much space is there inside a refrigerator? That is volume. 3 measurements, length, width, and height of the inside of the refrigerator. All right, hope you understand when to use which one now, and it's based on how many dimensions, how many measurements do you have to take. Now let's practice. Turn in your books, page 236. We're going to look now at cubes, cubic relationships. Okay? If the sides of a cube are 3 centimeters long. Okay, remember, what is the sides? The sides are the edges, the lines, okay? 3 centimeters long, that means each face is 3 by 3. So the area of each face, if it's 3 by 3, is 9 centimeters squared, okay? 3 by 3. Okay? And now, and that's the face in the front I'm talking about. Now what is the volume? We take the other line down here on the side, on the bottom, 3 dimensions, all connected to that vertex. If I take all 3 sides connected to a vertex, I have all 3 dimensions, and I multiply them. 3 times 3 is 9, and 9 times 3 is 27 centimeters cubed. Okay? Now what happens if we already know the volume? Look at number 11 and 12. If I already know the volume is 8 cubic meters, how am I going to figure out what each part is? Well, what is the length of each edge and what is the area of each face? Well, what can I multiply together 3 times because it's a cube, so all sides have to be the same? Well, how can I get 8? I can get 8 by taking 4 times 2. 4 times 2 is equal to 8. And then I can break up 4 into 2 times 2. That is 1, 2, 3, 2. So the length of each side, each edge, is 2 meters, because we're using meters this time. And the area of the face, 2 times 2, is 4 meters squared. Okay, we can take the answer we know and break it down into each piece. 13 to 14. One face of a cube has an area of 16 centimeters. So if we know this face area is 16, okay, what are the 2 sides of that face? Well, what do we multiply? That's the same number to get 16. I can multiply 2 times 8, but those are different numbers. But I can also multiply 4 times 4. So I know that 4 inches is the length of each side. So this is 4, and this is 4. And what is the volume? Well, I know 4 times 4 is 16, so I would take 16 times my height, 4, and that would equal 3264 inches cubed. Remember, if it's asking for length, we just write, well, I'll use inches for example, inches. If it's asking for area, we write the answer in inches squared. If it's asking for volume, it is inches cubed. The no number, which is assuming there's a 1, means how many dimensions. The 2 stands for 2-dimensional area. The 3 stands for 3-dimensional volume. All right, let's move on. We're going to skip the bottom page 236. Let's look over page 237 now. Doubling 2 dimensions of a figure. What are we going to do? How do we affect it when we double the dimensions? Okay, what are we actually doing? Well, let's take a look at this. Number 19. Louisa is making a quilt for Amanda. The quilt is 3 yards long and 2 yards wide. Amanda now wants the quilt to be twice as long and twice as wide. Well, what does that mean? Let me get my handy-dandy little adjustment thing out here. Pull this over here. That means this quilt, instead of being just 3, she wants the quilt to extend to be twice as long, so another 3 yards, making it total 6 yards, and twice as wide, another 2 yards here. Okay? Now, what is the area? That means my quilt is now going to be this big. How many of these original quilts can we fit in this area? Well, we look at it. When we double the length, making it from 3 to 6, and double the width, making it from 2 to 4, we actually have 1, 2, 3, 4 times as big a quilt. Okay, let's see what that looks like mathematically. The quilt is 3 yards long and 2 yards wide. So 3, whoops, forgot to do my pen again. 3 times 2 is equal to 6 yards squared. Well, if I double 3 and make it 6, and I double 2 to make it 4, 6 times 4 is 24 yards squared. It's 4 times bigger. Go back to our picture. There is the equivalent of 4 of the original. So it makes it 4. When you double both dimensions, it makes the area 4 times larger. Okay? And the new area would be 24 yards squared. Okay. Now, what does that mean when you talk about volume? Doubling all three dimensions. What does that do to the volume of something? Well, if doubling the two sides made it 4 times bigger, take that. Okay, now the area is 4 times bigger. Now I double the other one. Double that. Is it going to go to 8 times bigger? Let's find out. I want you to look at the dimensions of the box here. 3 by 2 by 1. 3 times 2 is 6 times 1 is 6 decimeters squared. I want you to double each of those, multiply it out, and tell me how much bigger the volume is than the original. Okay? In order, what can you multiply the original volume times to get the new volume you're going to get when you double all the sides? Pause your video, work this one out. All right, let's try this. So if I double 3, which is 3 times 2, I get 6. I double 2, 2 times 2 is 4. I double 1, 1 times 2 is 2. Now 6 times 4 is 24. 24 times 2 is 48 decimeters squared. Now what do I multiply 6 times to get 48? 6 times 8, which means the new volume is 8 times bigger. So when you double the area, like we did on number 19, you get an area. When you double each dimension, you get 4 times the area. When you double each dimension in volume, you get a volume 8 times larger. And ooh, look at this. I made a boo-boo and none of you caught it. This should be cubed. And this should be cubed because we're talking about volume. Yep, 3 dimensions. Area squared, number 2. Volume cubed, number 3. All right, let's look at 21 and 22. A garden is shaped like a rectangle. What happens to the area of the garden if you double the length and width of the garden? Okay, we don't need to know the length and width, because if we double each of those, we know from number 19, the garden is now 4 times bigger. Okay, now a box. Volume like we just did on number 20. A box is shaped like a rectangular prism. What happens to the volume of the box if you double the length of each edge of the box? Look at number 20. What just happened? That's right. If you double each dimension on a volume, you will get a volume 8 times larger. All right. Moving on. Which means it's homework time. All right. Today, oh, that's a skinny pin. We can't do that. Homework. And remembering 6-2. All right. This homework and is due on Tuesday after your long weekend. I take that back. Homework's due tomorrow. I'm off on my days. So make sure you have this homework done. Homework and remembering 6-2. You're going to be working with comparing length, area, and volume, how many dimensions they are, and putting them into practice. All right. Good luck.